This video here looking at half-life, and the definition of half-life is the time needed for half of a sample, and that sample needs to be radioactive, so it needs to decay into something stable. So what you see here is during each half-life you lose half. So we go from 10 to 5, from 5 to 2.5, from 2.5 to 1.25, and so on. And this continues until you end up with nothing. So it looks like here for strontium-90 the half-life is about 28, 29 maybe. And again, that half-life, that time stays constant, where each time we get to a half-life we lose 1/2 of the amount we initially had. So just some common isotopes, something we'll probably talk about in the future, some carbon-14 used for dating artifacts. So if you dig something up you can find how old it is based on the amount of carbon-14 left. Some cobalt-60 used for cancer therapy, so because it produces those gamma particles we can use it to mutate the DNA in a cancer cell and keep it from reproducing. And a whole bunch of other ones, plus there's many more that are radioactive. So example number 1, if an isotope of cesium-137 has a half-life of 30 years, if 1 gram is left to decay for 90 years, how much would remain? Well, if I take that time divided by the half-life, that gets me the number 3. Well, that's 3 half-lives have passed. So after the first half-life, let me fix the screen here. Try this again. So after the first half-life, we are down to 0.5 grams. This would be the second half-life. We are down to 0.25. So I'm just dividing what I had by 2 until finally I end up with, after the third half-life, after that final 30 years, I end up with 1.25 grams as my answer. So pretty simple, you're just going to be dividing by 2 or multiplying by 2 for most of these questions. So in 2000 you buried 15 kilograms of carbon-14 in your backyard. Someone digs it up in year 13460. Given carbon-14 has a half-life of 5,730 years, how much did they find? Well, how much time has passed? So if we look at time passed, that's 13,460 minus year 2000 gets me 11,460. So this is how many years have gone by. If we look at that number and divide by how long 1 half-life is, so 11,460 divided by 5,730, that comes out to be 2. Well, 2, that's 2 half-lives. So how much did they find? Keep going here. I told you, so 2 half-lives, which is half of a half, kind of a weird way of thinking of it, or 1/4. So my number didn't space correctly, but if we look at that, 15 times 2 equals 7.5, divided by 2 again for my second half-life gives me 3.75, and our label here, kilograms, as our answer. So first half-life here, second half-life gets us to our answer. Example number 3, if an isotope has a half-life of 10 years, how long would it take for a 30-gram sample to decay to 3.75? So a little different question. This time it's asking you how long, where the others was asking you how much is left over. You can be asked either it's really the same process. You're going to take a number, divide by the other one. So for something like this, take the big number, so take 30 grams, and divide by the smaller one, 3.75 grams. What this is going to give us, the number of half-lives that have passed. So we look at the math here, that equals 8. So 8 half-lives have gone by. That gives us a factor of 8. What we're trying to figure out is how many half-lives have gone by, or 2 to the what power equals 8. Well, if you think about, 2 times 2 equals 4, so that's 1 times 2, 1, so that's 1 2. There's 2 2's times a third 2 gets me to 8. So that question mark equals, so 2 to the third power equals 3. What that means is 3 half-lives have passed. So don't just think this number is 8 and go 8 times 10 and I'm done. It's really, okay, how many times, how many half-lives would get me to 8? So 2 to the what power? So don't kind of fall into that trap there. So then, okay, if we have 3 half-lives, well, if one half-life is 10 years, our final answer there, 30 years to finish up. Just kind of a quick review if you didn't pick up on it. Half-life is nothing more than, if you want to think powers of 2 or powers of 1/2. So just kind of remind yourself of what each of those, so the next one, 32, the next one 64, same thing here, 1/2, 1/4, 1/8, 16th. You are always going to have powers that work out, or you're always going to have questions that will somehow work out perfectly to an exact half-life. There is a larger equation for this, but we're just going to work in powers of 2. So familiarizing yourself, if I could say that word, with these powers of 2 and just kind of noticing that is something that'll help you.